New observations of an interstellar object 3I Atlas over the past few days from astronomers around the world have noticed that this shifting from a green colour to a gold colour is very unusual. You don't often see gold-coloured comets, or in this case an interstellar object. The object is shifting, transforming right before our eyes, changing from the vivid green colour that dominated its appearance through October and November into a striking golden hue that's unlike anything we've seen before. And this is very unusual, profoundly unusual. You don't often see gold-coloured comets, and you certainly don't see gold-coloured interstellar objects. In fact, before we go any further into this mystery, before we unpack what this colour transformation means and why it might signal something momentous about to happen, if you want to stay on top of these developments as they unfold in real time, if you want to understand what's happening to this object from another star system as it executes what might be its final act in our solar system, smash that subscribe button right now and hit the notification bell. We are tracking 3I Atlas daily with fresh observations coming in from observatories worldwide, and what happens in the next few weeks could be historic. Don't miss it. This gold colour shift isn't just aesthetically interesting. It's not just a pretty change that makes for nice images. It's a fundamental indicator of chemical evolution, of processes happening on and in the nucleus that are transforming the composition and structure of this object in ways we can measure and analyse. And here's what makes it especially significant. We do have another comet, C2025 K1 Atlas, right now in our solar system, an unrelated object from our own Oort cloud that about 6 weeks ago shifted to a golden hue as it moved into the constellation of Leo. That timing is quite interesting, that synchronicity between two different objects exhibiting similar colour transitions within weeks of each other. And shortly after C2025 K1 Atlas took on that golden colour, after it made that shift from its previous appearance, it actually started to fragment apart, to break into multiple pieces as structural stresses exceeded the cohesive strength holding the nucleus together. The object literally came apart, disintegrating in a way that completely changed its character and its future evolution. So the question we have to ask, the question that's driving intensive observation campaigns right now is this: is the gold colour shift we're seeing in 3I Atlas indicative of a new chemical change and evolution occurring right now in real time? And maybe, perhaps inevitably, is it going to break apart in the near future as it continues on its trajectory heading toward Jupiter? That's a critically important question because fragmentation would dramatically alter what we can learn from this object, would change the observational signatures, would potentially reveal internal structure and composition in ways an intact nucleus cannot. The evidence we've accumulated over the 5 months since 3I Atlas was discovered suggests a fascinating thermal and compositional history. The most compelling interpretation, the scenario that best fits all the observations we have, is that 3I Atlas was once, billions of years ago in its origin system, probably a short-period comet orbiting relatively close to its host star. We don't know what that star was, what spectral type, what luminosity, what planetary system context, but we can infer from the object's properties that it experienced repeated close approaches, that it was heavily thermally processed from hundreds or even thousands of orbits around that star over millions of years. That prolonged thermal processing, that sustained exposure to stellar heating cycle after cycle, would have driven off the most volatile components, would have baked the nucleus, would have created a crust of refractory material and organic compounds that were altered by radiation and heat into the complex molecules we call tholins. That's why it came into our solar system, after its long journey through the cold, dark isolation of interstellar space lasting millions or billions of years, with a very dark red colour, a deep ruddy hue dominated by organic-rich material coating its surface. And then something remarkable happened as it approached our sun. As solar heating began to penetrate that ancient crust, it suddenly erupted with activity, began outgassing prodigiously, started glowing green, as fresh, volatile-rich material from the interior was exposed and began sublimating, releasing gases that fluoresce under solar ultraviolet radiation. The green came primarily from diatomic carbon, C2 molecules, produced when larger carbon-bearing molecules in the coma were broken down by solar photons. There was even a little blue at times, hints of ionized carbon monoxide emission, when particularly intense outbursts created high-density regions in the coma, where ionization was efficient. And now, in mid-December 2024, as we record these observations, with that final eruptive phase having apparently come to an end, with the most volatile reservoirs seemingly exhausted, it seems the object is transitioning back to a dust-dominated appearance. But it's not returning to the original red. Instead, it's glowing gold, taking on this striking metallic yellow-gold coloration as it moves through space, as it also happens to be moving into the constellation of Leo over the next couple of weeks, and into early 2026. Leo, the lion, the symbol of kings and royalty in ancient mythology, traditionally associated with the colour gold, with solar imagery, with regal symbolism. And 3i Atlas is approaching Jupiter, the planet of kings in astrological tradition, the gas giant whose name comes from the ruler of the Roman pantheon. So a lot of very interesting things, both scientifically measurable and symbolically resonant, are happening right now with 3i Atlas. And we're going to unpack all of that, dissect what the observations tell us, examine what the colour shifts mean chemically and physically, explore what might happen during the approach to Jupiter, and consider whether there are connections beyond pure coincidence in the timing and symbolism we're witnessing. This is going to be comprehensive, detailed, grounded in the data, but willing to ask questions that conventional analysis might shy away from. Let's begin with some of our first imagery of interstellar object 3i Atlas, going back to the discovery period in early July 2024, when the object was first detected by the Atlas survey system. Here we have 3 different observational bands, different wavelengths that reveal different aspects of the object's composition and activity. Our G-band observation, using a green filter centered around 520 nanometers, our R-band using a red filter around 650 nanometers, and our near-infrared band extending beyond visible wavelengths into thermal emission regime. These images go back to July 30th, 2024, about a month after initial discovery on July 1st. Remember, the discovery itself was somewhat serendipitous. Atlas isn't specifically designed to find interstellar objects. It's primarily an asteroid impact hazard survey, scanning the sky repeatedly looking for near-Earth objects that might pose collision risk. But its wide field coverage and sensitive detectors make it capable of detecting unusual objects that move differently than typical solar system bodies. When 3i Atlas appeared, its motion immediately flagged it as potentially interstellar, moving on a trajectory that didn't match anything in the known catalogue of asteroids and comets. Follow-up observations quickly confirmed the hyperbolic orbit, the excess velocity, the clear interstellar origin. In those early July observations, looking at the green band imagery, you notice something immediately striking. It's not glowing green at all, despite being observed through a green filter. The object appears more yellow, more neutral in colour, not showing the characteristic green emission that would indicate strong C2 production. This tells us that in its initial active phase, diatomic carbon wasn't dominating the coma emission. The chemistry was different, the volatiles being released were different species, but in the red optical imagery from the same period, it's glowing intensely, showing very strong emission in red wavelengths. That red glow, that deep ruddy colour, is the signature of the ancient organic crust we mentioned. The tholins accumulated over billions of years of cosmic ray exposure and thermal cycling during its interstellar journey, and that red coloration persisted, remained dominant in observations across all the different observing campaigns, from discovery through July through August, all the way until about the end of September, when something changed, when the colour dramatically shifted to green. The infrared observations from July show the object glowing quite brightly in thermal emission, confirming high temperatures on the sun-facing hemisphere, significant thermal radiation being emitted as absorbed solar energy was re-radiated at longer wavelengths. This is important because thermal emission intensity tells you about surface temperature and about how efficiently the surface absorbs and re-emits solar energy. Remember, 3i Atlas was very active even from the first day that we detected it, even at the large solar distances where it was initially observed. It entered our observable solar system after its long journey through cold, dark interstellar space where temperatures hover just a few degrees above absolute zero, and it effectively immediately started becoming active once solar heating reached significant levels. This immediate activation upon detection speaks to a critically important structural characteristic. There was likely only a very thin crust of material surrounding the nucleus, a fragile shell that was easily penetrated by solar heating. The object didn't need to be deeply, thoroughly heated by our sun over weeks or months to suddenly start outgassing. It didn't require prolonged warming to drive sublimation from interior reservoirs. Instead, activation was rapid, almost instantaneous on astronomical timescales, suggesting that the volatile-rich interior was separated from space by only a minimal insulating layer. This is consistent with the thermal history we proposed, a nucleus that was heavily processed during its origin system lifetime, baked by repeated stellar approaches that drove off surface and near-surface volatiles, then accumulated a fresh veneer of volatile ices and organics during its interstellar journey. That accumulated material would form a thin heterogeneous crust, not a thick uniform mantle, explaining why breakthrough to interior reservoirs occurred so quickly once solar heating became significant. As we move forward in time toward the present moment, examining observations from late August, we see the transition beginning. Here we have imagery of Interstellar Object 3I Atlas from August 27th, showing 4 different wavelength bands. Ultraviolet revealing the highest energy emissions from ionized atoms, green band showing C2 and other molecular emissions, red band capturing organic-dominated reflected light and emission, and infrared showing thermal emission from the warmed surface. In the green band, you can see it's starting to show more prominent emission, the characteristic green glow intensifying as C2 production ramped up. But it's still very strongly visible in the red band, still dominated by that organic-rich crustal material. This observation was captured when the object was at 2.59 astronomical units from the Sun, and that distance is critically important because it places 3I Atlas right at what astronomers call the water snow line or water sublimation boundary. This is a distinct zone at approximately 2.5 AU where temperatures reach the threshold, where water ice transitions from being essentially inert, stable, against sublimation on human timescales, to becoming actively volatile, sublimating readily and contributing significantly to cometary activity. Below 2.5 AU, as you approach the Sun, water ice dominates the gas production from most comets. Overwhelming contributions from more volatile species like CO and CO2 that were active at large distances. So this August 27th imagery captures 3I Atlas right at the moment when water began becoming a major player in the chemistry, when H2O sublimation started influencing the coma composition significantly. And this transition, this activation of the water ice reservoir, would fundamentally change the appearance and behavior of the object, because water sublimation releases embedded dust much more effectively than super volatile ices do, and water photodissociation produces OH radicals that themselves have strong ultraviolet emissions. And then in September, we witnessed the dramatic shift, the transformation that caught everyone's attention and generated intense observational campaigns. The colour changed from red to green, definitively and unmistakably, as C2 emission came to dominate the coma's optical appearance. Before September, before that transition, the dominant species being released were primarily carbon dioxide, CO2, which doesn't produce strong optical emission, and cyanide compounds, specifically CN radicals that emit in the ultraviolet and violet but don't contribute to green coloration. There was also that mysterious nickel emission that appeared very early in the observation sequence, strong spectroscopic lines from neutral nickel atoms in the coma appearing without corresponding ion emission, a chemical signature we'll explore in much more detail because it tells us something profound about the nucleus composition and structure. And then, in September, cyanogen gas, diatomic carbon molecules emerged and intensified rapidly. This C2 emission ramped up sharply, much more dramatically than expected based on standard cometry models. The brightness and green wavelengths increased by factors of 10 or more over just weeks, indicating that whatever reservoir was feeding C2 production had been breached, that fresh carbon-rich material was being exposed and processed. If we jump forward substantially in time, all the way to late November after perihelion passage, we see evidence of yet another transition beginning. Here we have high-resolution imagery from Gemini North Observatory, dated November 26th, roughly a month after the October 28th perihelion, when 3I Atlas made its closest approach to the Sun at about 1 AU. And you'll notice something interesting in this image. The object has taken on a slight bluish tinge in some regions of the coma, a subtle blue coloration that indicates ionized carbon monoxide, emission CO+ ions that fluoresce in blue wavelengths under solar radiation. There's still greenish color present, still some C2 contribution, but you can also see the beginnings of a transition toward more golden, more yellowish tones in the inner coma regions. This suggests that the object is evolving again, shifting chemical states as the most volatile reservoirs become depleted and as the dust-to-gas ratio in the coma increases. So Gemini North caught this intermediate phase, this transition state between the bright green appearance that characterized October and early November and the golden appearance that would come to dominate by mid-December. The Gemini image is particularly valuable because of its exceptional spatial resolution, the ability to see fine structure in the coma and to resolve details about jet morphology and dust distribution. You can see asymmetries, non-uniform brightness, indications that the outgassing wasn't coming uniformly from the entire nuclear surface, but was concentrated in localized active areas, vents or fractures where subsurface pressure could escape explosively. This structure matters because it tells us about the nucleus geology, about how crust thickness varies across the surface, about where the volatile reservoirs are located relative to zones that became exposed to direct solar heating. And now, in mid-December, we have multiple independent observations confirming that 3I Atlas has taken on a striking gold colour, a metallic yellow-gold hue that makes it visually distinct from both its earlier red phase and its intermediate green phase. This image, taken on December 10th by amateur astronomer Alberto Quijano Vodniza, shows the gold coloration clearly, unambiguously. The object isn't red anymore, it isn't green, it's gold, showing maximum brightness in yellow wavelengths, reflecting and emitting in ways that create this characteristic golden appearance that's both beautiful and scientifically significant. This is very interesting, this sequence of colour transformations, because we've now documented 3 distinct phases: red dominated by organic-rich crustal material, green dominated by C2 molecular emission from volatile-rich interior material, and now gold dominated by dust-rich coma, where small particles scatter sunlight in ways that produce yellow-gold coloration. And this evolution is occurring as 3I Atlas moves through space on its outbound trajectory, as it's traversing the boundary between constellations Virgo and Leo, as it's approaching its closest distance to Earth, which occurs in just 4 days from this recording on December 19th under optimal new moon viewing conditions. And that December 19th closest approach is also coinciding with 3I Atlas moving definitively into the boundaries of Leo, crossing from Virgo into the constellation associated with lions, with solar imagery, with kingship and royalty in ancient symbolism. Anyone who has the capability, anyone with telescopes and cameras suitable for deep sky imaging, should definitely try to observe 3I Atlas on December 19th, because viewing conditions will be perfect. New moon means dark skies, no lunar interference. The object will be well placed in the pre-dawn sky, fairly high above the horizon for mid-northern latitude observers, providing good atmospheric transparency and minimal extinction. But this shift to gold, this transformation we're witnessing, isn't just a one-off observation by a single amateur astronomer or small group. Science requires replication, requires confirmation from multiple independent sources, using different instruments under different conditions. That's how you distinguish real phenomena from artifacts, from instrumental effects, from mistakes. And the key here is to look at multiple observations across the board, across different observers in different locations using different equipment, because that's how you can get a robust sense of what's actually happening to this object, and we have extensive confirming imagery. Here's an observation from December 14th, just 2 days ago from this recording, showing 3I Atlas in less vividly coloured presentation than some images, but critically not showing obvious green coloration. The absence of green is itself significant confirmation that the C2 dominated phase has ended. The coma isn't glowing green anymore. That bright emerald colour that characterised the object through October and November has faded, has been replaced by more neutral yellowish gold tones, indicating that whatever was driving intense C2 production has been exhausted or covered over. And we have more imagery from December 15th, from today, as I record this analysis. Look at the colour in this observation. It's clearly trending golden, showing that characteristic yellow-gold hue in the coma though, with perhaps hints of residual green in the brightest innermost regions. This is almost a combination, a transitional state capturing the final traces of green emission, being overwhelmed by the increasing dominance of dust scattering that produces gold coloration. This image from Tony Scamato, observing from Italy, adds to the growing database confirming that we are witnessing a profound colour shift, a transformation that speaks to fundamental changes in the physical and chemical state of the nucleus. And it just seems, based on the accumulating evidence from dozens of observers worldwide, that we're seeing the completion of a colour evolution cycle that reflects 3I Atlas's primordial history, its journey through interstellar space, its activation in our solar system, and now potentially its final phase before possible fragmentation or other dramatic changes as it continues toward Jupiter. This is an object whose entire life cycle is playing out before us in compressed time, in ways we can document and analyse, providing unprecedented insights into how interstellar visitors behave when they encounter stellar radiation after millions or billions of years in the cold dark between stars. So we have documented the observational sequence, the visible transformation from red through green to gold that defines 3I Atlas's evolution in our solar system, but observations without physical understanding remain descriptive rather than explanatory. To truly comprehend what's happening to this interstellar visitor, we need to examine the chemistry, the atomic and molecular processes that produce these colour signatures, the physical mechanisms that drive the transitions we're witnessing, and that examination reveals a story far more fascinating than simple sublimation of ice under solar heating. It reveals a complex thermal and chemical history that spans billions of years and multiple stellar environments. Let's start by carefully analysing the pre-perihelion observations, the data collected from discovery in early July through October 28th, when 3I Atlas made its closest approach to the Sun. During this inbound phase, as the object was approaching perihelion, falling deeper into the Sun's gravitational well and experiencing ever-increasing solar heating, we documented very specific chemical signatures that tell us about composition and about what materials were being released from the nucleus into the coma, where they could be detected spectroscopically. The most striking characteristic of early observations, the feature that dominated from discovery through mid-September, was that vivid red colour we discussed. When you look at images taken in red optical wavelengths, in the R-band centered around 650 nanometers, 3I Atlas was extraordinarily bright, intensely red, showing emission and reflection dominated by wavelengths in that part of the spectrum. And that red coloration was remarkably stable throughout the entire early observation period. Despite increasing activity as the comet approached the Sun, despite steadily rising gas and dust production rates, despite more and more material entering the coma and being exposed to solar radiation and being ionized and fluorescing, the red color remained dominant, remained the defining visual characteristic. This stability is itself telling because it indicates that whatever material was producing the red color wasn't being depleted rapidly, wasn't being exhausted even as overall activity increased. The red component was either very abundant, present in large quantities that could sustain the coloration for months, or it was being continuously replenished from surface layers being eroded away by sublimation of underlying volatiles. And the red colour, as we established, comes primarily from organic compounds, specifically from complex carbonaceous materials called tholins that form when simpler hydrocarbons and nitrogen-bearing molecules are irradiated by UV light and cosmic rays over geological timescales. The comparison to previous interstellar visitors is illuminating and highlights just how unusual 3I Atlas is in its composition and behaviour. Oumuamua, the first confirmed interstellar object discovered in 2017, was very, very dark, extremely low albedo, reflecting only about 10% of incident sunlight, making it one of the darkest objects ever observed in our solar system. That darkness suggested a surface dominated by carbon-rich material that had been space-weathered over millions or billions of years, perhaps similar to carbonaceous chondrite meteorites, or to the surfaces of D-type asteroids that we see in the outer main belt and among Jupiter Trojans. Borisov 2I Borisov discovered in 2019 was much more normal in appearance and behaviour, showing characteristics very similar to typical Oort cloud comets from our own solar system. It had a more neutral colour, reflecting sunlight without strong reddish or bluish tints. Its gas composition matched solar system comets closely. Its dust-to-gas ratio was typical. In many ways, 2I Borisov told us that comets from other stellar systems can be very similar to comets from our own system, suggesting that the physical and chemical processes that form comets are fairly universal across the galaxy, or at least across regions with similar metallicity and formation conditions. But 3I Atlas is bizarre, distinctly unusual, even compared to the already strange Oumuamua. The intense red coloration, far more pronounced than typical comets show, indicates either an exceptionally organic rich composition or a surface that has been exposed to particularly intense radiation processing. And then there are the other chemical oddities, the spectroscopic signatures that don't match standard cometary patterns, signatures that demand explanation and that may hold keys to understanding where this object came from and what it experienced before entering our solar system. The most mysterious and most discussed chemical signature is the nickel emission that appeared very early in the observation sequence, detected spectroscopically within weeks of discovery when 3I Atlas was still at large solar distances where most comets show minimal activity. Spectroscopy works by spreading light into its component wavelengths, creating a spectrum where bright emission lines appear at specific wavelengths corresponding to atomic transitions in specific elements or molecular transitions in specific compounds. Each element produces a unique fingerprint of emission lines when its atoms are excited by UV radiation or electron collisions. By identifying which lines are present and measuring their strengths, we can determine which elements are in the coma and in what abundances, and the spectrum of 3I Atlas showed strong nickel lines, emission from neutral nickel atoms in the coma that were being excited by solar UV and re-emitting at their characteristic wavelengths. If you've been tracking this story through previous videos and reports, you'll know this nickel detection has been a topic of intense discussion because nickel in cometary comae, while not unheard of, is unusual. Most comets show weak or undetectable nickel emission. The few that do show it typically also show strong ion emission, because nickel and iron are chemically similar, both hydrophile elements that occur together in most natural environments, and most cosmic materials have nickel to iron ratios reflecting the cosmic abundance ratio of about 117. But here's what made the 3I Atlas nickel detection so striking and so puzzling. There was basically no increase in ion emission at the same time. The spectrum showed strong nickel lines appearing and intensifying, but the iron lines that should have appeared alongside them, that should have tracked with similar behaviour if nickel and iron were being released together from the nucleus, those iron lines remained weak or absent. This is chemically bizarre because it requires some process that can release nickel into the coma while somehow sequestering iron, preventing it from reaching the gas phase where it would be detectable spectroscopically. Now I want to be very clear about what this observation does and doesn't tell us because there's been some confusion and speculation that isn't supported by the data. The nickel detection without corresponding iron does not mean that the nucleus of 3I Atlas has no iron. It doesn't imply that the solid body is deficient in iron relative to cosmic abundances or relative to expected cometary composition. What it means is that if there is iron in the nucleus, and there almost certainly is iron present in the rock and mineral phases that comprise the non-volatile fraction, that iron is not reaching the coma in detectable quantities through whatever process is releasing nickel. We're only observing the coma here, the gas and dust that has been ejected from the nucleus and is now surrounding it, the material that can be probed spectroscopically because it's being illuminated by sunlight and is emitting or absorbing at characteristic wavelengths. We're not directly observing the nucleus composition, not seeing what elements are present in the solid body itself. So there's clearly some selective process occurring, some mechanism that can transport nickel from the nucleus into the coma, that can convert solid phase nickel into gas phase atomic nickel, that isn't operating equally efficiently for iron despite the chemical similarities between these two elements. And here's where the chemistry gets really interesting, where we can propose a specific mechanism that explains the observations in a natural way that doesn't require exotic processes or materials. The key concept is metal carbonyls, specifically iron carbonyl and nickel carbonyl. These are fascinating compounds where metal atoms, typically transition metals like iron and nickel, form coordinate covalent bonds with carbon monoxide molecules. The metal atom sits at the centre of a geometric arrangement of CO molecules, typically 4 or 5 CO ligands surrounding the metal, creating highly volatile compounds that can exist as gases or low melting point liquids. Metal carbonyls are important industrially because they allow extraction and purification of metals through gas phase chemistry. They form naturally in reducing environments where both metals and carbon monoxide are present, and crucially for our analysis, they can form in cometary nuclei where metallic particles or minerals are embedded in carbon monoxide-rich ice. As the ice warms and CO begins sublimating, it can react with exposed metal surfaces forming volatile carbonyl compounds that then sublime along with the ice, entering the gas phase and being carried into the coma. What we know from laboratory chemistry and from industrial applications is that nickel carbonyl, NiCO4, is significantly more stable than iron carbonyl, FeCO5, under the temperature and pressure conditions relevant to cometary environments. Both compounds can form, both are volatile enough to sublime at temperatures where carbon monoxide ice is actively sublimating. But iron carbonyl is chemically reactive, prone to decomposition, or to reacting with other species present in the mixture. It can react with water, for example, oxidizing the iron and breaking apart the carbonyl complex before the compound reaches the coma. Nickel carbonyl, by contrast, is more robust, more resistant to decomposition and side reactions. It can form in the nucleus interior where CO ice and nickel-bearing minerals are in contact, can sublime when the ice sublimates, can make it through the crust and into the coma before being broken apart by solar UV radiation. Once in the coma, once exposed to intense solar UV, the carbonyl compound photodissociates, UV photons breaking the NiCO bonds, releasing free nickel atoms and CO molecules. Those freed nickel atoms then get excited by additional UV photons, causing electronic transitions that produce the emission lines we detect spectroscopically. So the mechanism is beautifully simple and entirely natural. Nickel carbonyl forms in co-rich regions of the nucleus where metallic nickel is available, sublimates efficiently due to its high volatility, survives transport through the crust without being destroyed by reactions, reaches the coma where solar UV dissociates it, releasing nickel atoms that then produce the observed spectroscopic signature. Iron, despite being chemically similar, and despite presumably being present in the nucleus at much higher abundances than nickel, doesn't reach the coma efficiently because iron carbonyl is less stable, more reactive, more likely to be destroyed during the journey from nucleus interior to coma, resulting in the puzzling spectroscopic pattern where nickel appears without corresponding iron. This interpretation, this carbonyl-based explanation, is quite sophisticated, but it's also quite plausible, and it doesn't require invoking anything exotic or unknown. It uses well-understood chemistry that's been studied extensively in laboratories and industrial settings, and applies it to the specific conditions present in a comet nucleus. But here's what makes this chemically significant beyond just explaining an observational puzzle. The presence of substantial carbonyl formation speaks to the nucleus's thermal history and composition in profound ways. Metal carbonyls form efficiently only in strongly reducing environments, conditions where oxygen is scarce or bound up in other compounds, and where carbon monoxide is abundant and available to react with metals. They form preferentially at low temperatures where the carbonyl compounds are thermodynamically stable, and they require intimate contact between volatile CO ice and metal-bearing minerals or particles. All of these conditions point toward specific formation scenarios and specific evolutionary histories that shaped 3I Atlas into its current state. The most likely scenario, the interpretation that best synthesizes all the evidence we have from composition and color and behavior, is that 3I Atlas was once, in its origin stellar system billions of years ago, a short-period comet orbiting relatively close to its host star. Short period in this context doesn't mean days or weeks like hot Jupiters orbiting stellar atmospheres, but rather years to perhaps a few decades. Close enough that stellar heating was significant during each perihelion passage, far enough that the comet could survive multiple approaches without being completely destroyed. Over hundreds or thousands of orbits spanning millions of years of active lifetime in that system, the comet would have been repeatedly heated to temperatures high enough to drive off the most volatile components. Water ice would have sublimated cycle after cycle. Carbon dioxide would have been depleted. Methane, ammonia, all the supervolatiles that form the initial endowment of pristine comets, condensing in outer regions of protoplanetary disks, these would have been baked away, leaving a nucleus that was depleted in volatiles, that had lost its initial inventory of easily sublimated ices. What remained after this prolonged thermal processing would have been primarily refractory material, silicates and carbonaceous minerals and complex organics that couldn't be volatilized at the temperatures reached during perihelion passages. The nucleus would have become darker, redder, more organic-rich as the ices were driven off and as the remaining organics were irradiated and transformed into tholins. This is exactly the state we see in very old, thermally evolved comets in our own solar system, objects that have made many perihelion passages and show depleted volatile inventories. And then something dramatic happened. Gravitational perturbation from a planet or stellar encounter or some other dynamical process ejected the comet from its origin system, sending it on a hyperbolic trajectory that carried it out of the stellar gravity well and into interstellar space. This ejection is the critical transition, the moment when 3I Atlas began its long journey through the dark, cold regions between stars where temperatures hover just a few Kelvin above absolute zero, where stellar radiation is negligible, where the dominant radiation field is the cosmic microwave background and the diffuse glow of integrated starlight. During that interstellar journey, which may have lasted millions or billions of years depending on the distance travelled and the ejection velocity, the object gradually accumulated a fresh veneer of volatile materials from the interstellar medium. Interstellar space, despite being an incredibly good vacuum by terrestrial standards, with number densities measured in atoms per cubic centimetre, rather than molecules per cubic metre, is not completely empty. It contains gas, primarily hydrogen, but with traces of heavier elements. It contains dust, tiny particles of silicates and carbonaceous material and ices, and it contains molecules, simple compounds like H2 and CO and H2O, that form either in stellar outflows or through gas phase chemistry in molecular clouds. As 3I Atlas travelled through this medium, moving at velocities of tens of kilometres per second relative to the local interstellar gas, it would have swept up material, accreted atoms and molecules and dust grains onto its surface. This is accretion through relative motion, rather than through gravitational attraction. The object is far too small to gravitationally capture significant material at interstellar densities. But direct impact of particles onto the surface, sticking through van der Waals forces or chemical bonding or simple mechanical trapping in surface irregularities, this could gradually build up layers of accumulated material over millions of years. The accumulated material would be predominantly water ice because water is one of the most abundant molecules in interstellar space, forming readily on grained surfaces and being released into the gas phase by various processes, but it would also include carbon monoxide, which is stable in cold environments and abundant in many interstellar regions, and it would include organics, complex carbon-bearing molecules that form through radiation chemistry and that are detected throughout the galaxy in molecular clouds and around young stars. This fresh accumulation would coat the ancient thermally processed nucleus, creating a heterogeneous structure with a depleted interior and a volatile rich surface layer. And crucially, this accumulated material would be a one-time acquisition for 3I Atlas, unless the object survives its solar system passage intact and continues travelling through space for another millions of years. The accumulation during the interstellar journey was possible because the journey was long and because the object was immersed in the interstellar medium continuously. But once ejected from our solar system after this brief visit, once travelling through the relatively empty regions of interplanetary space in the outer solar system and beyond, there won't be material available to accumulate. The veneer of volatiles accumulated during the interstellar journey represents a finite reservoir that gets depleted through sublimation as the comet approaches the Sun. As the object entered our solar system, as solar heating began to penetrate the surface and warm interior layers, this finite volatile reservoir became activated. The thin crust of accumulated material, not having time to consolidate into thick insulating layers, was easily breached by thermal conduction. Subsurface ices reached sublimation temperatures rapidly, once solar flux exceeded critical thresholds. The comet transitioned suddenly from dormant to highly active, from dark and inert to brightly glowing and outgassing prodigiously. At its closest approach to the Sun at perihelion, 3I Atlas was receiving about 735 watts per square metre of solar radiation at the subsolar point, the location on the nucleus where the Sun is directly overhead. This is the solar constant at 1 AU, the standard irradiance that Earth's atmosphere intercepts. Contrast this with the interstellar environment where the radiation field is incredibly weak, about 10^7 to 10^8 watts per square metre from the integrated glow of all distant stars and from cosmic microwave background. That's a difference of 10 orders of magnitude, a factor of 10 billion increase in the energy flux reaching the surface. Such a dramatic increase in heating drives rapid, often violent responses in volatile-rich materials. Sublimation rates increase exponentially with temperature following the Clausius-Clapeyron relation. Small temperature increases produce large increases in vapor pressure, and therefore in gas production rates. For a nucleus that contains trapped volatiles under a thin crust, The temperature rise can build subsurface pressure faster than gas can escape through pores and cracks, creating conditions for explosive breakthroughs where chunks of crust get blown off suddenly, exposing fresh material that then outgasses rapidly. And if this thermal history scenario is correct, if 3I Atlas really did experience this sequence of thermal processing in its origin system, followed by volatile accumulation during interstellar journey, followed by sudden reactivation in our solar system, then what we're seeing now as it shifts to gold colour represents the final phase of this evolution. The accumulated volatiles have been sublimated, driven off during the intense activity periods of October and November. The finite reservoir that was built up over millions of years has been exhausted in just months of exposure to solar heating. Now the remaining material dominating the coma is dust. Particulates eroded from the surface as sublimating ices dragged them along, fragments of the ancient refractory nucleus that survived thermal processing eons ago. And this dust-rich coma produces the gold coloration we're observing because dust particles scatter sunlight differently than gases do, differently than molecular emissions do. Small particles comparable in size to the wavelength of visible light, grains measured in micrometers, scatter sunlight through me-scattering processes that favour certain wavelengths over others, depending on particle size and composition. For organic-rich dust, for particles composed of carbonaceous material similar to that found in primitive meteorites, the scattering efficiency tends to peak in yellow wavelengths, producing the characteristic gold colour we're seeing in recent images. The organics that give the dust its composition, those same tholins that produced the red colour when they dominated reflected light from the nucleus surface, now dispersed into a cloud of particles, produce yellow-gold scattered light when suspended in the coma as small grains, creating the beautiful golden halo around the nucleus that observers worldwide are documenting in their images captured during these critical weeks of December 2024, when humanity watches an interstellar visitor execute what may be its final transformation before fragmentation or disintegration or some other dramatic transition that will fundamentally change its appearance and its evolution, and that we're positioned perfectly to observe and analyze and understand if we pay attention carefully and document thoroughly and think critically about what the changing colours and compositions and behaviours tell us about where this enigmatic object came from and what it represents. So we understand the chemical history, the thermal processing that shaped this object, the interstellar accumulation that created the volatile reservoir, the solar system activation that depleted that reservoir, and the transition to dust-dominated gold coloration we're witnessing now. But understanding the past doesn't tell us what happens next, and what happens next is the urgent question driving observation campaigns as December 19th approaches, as viewing conditions optimize, as 3I Atlas executes maneuvers through space that will determine whether it remains intact or breaks apart, whether it continues as a single object or fragments into multiple pieces that follow slightly different trajectories. The precedent, the recent analogue that everyone is watching carefully and comparing against, is C2025 K1 Atlas, that unrelated solar system comet that exhibited a remarkably similar sequence of colour changes. K1 Atlas, like 3I Atlas, transitioned from relatively neutral coloration to a pronounced golden hue as it moved into the constellation Leo roughly 6 weeks ago from this December 15th recording. The timing of that colour shift, the association with Leo, the development of the gold appearance, all of these parallels are striking, even though the two objects have completely different origins and completely different trajectories. And what happened to K1 Atlas after it turned gold? It fragmented. The nucleus broke apart into multiple distinct pieces that could be resolved separately in high-resolution images that followed diverging paths as each fragment experienced slightly different forces from outgassing and solar radiation pressure. Fragmentation isn't uncommon in comets. Many comets split during perihelion passages when thermal stresses and internal pressure from sublimation exceed the structural strength of the nucleus. Famous examples include Comet Shoemaker Levy 9, which broke into more than 20 pieces before impacting Jupiter, or Comet 73P Schwarzmann-Wachmann 3, which fragmented into dozens of components during a close solar approach. But the timing with K1 Atlas, the fact that fragmentation began almost immediately after the gold colour shift, suggests a possible causal connection rather than just temporal correlation. The gold colour indicates dust domination, which implies that volatile reserves have been largely exhausted. that the nucleus has lost the material that was actively sublimating and creating internal pressure and providing a kind of structural support through the pervasive outgassing. Without active volatiles buffering stresses, without the cushioning effect of sublimation, absorbing energy, and redistributing forces, the nucleus becomes more vulnerable to thermal stresses, to differential expansion and contraction, to the accumulated effects of repeated heating and cooling cycles. So the question naturally arises, is the gold colour shift we're seeing in 3I Atlas indicative not just of a chemical change but of impending mechanical failure? Are we watching the final phase before structural disintegration? The evidence is circumstantial but concerning. Like K1 Atlas, 3I Atlas has transitioned to gold. Like K1 Atlas, this transition is occurring as the object moves into Leo. Like K1 Atlas, the timing comes after intensive activity periods when volatiles were being depleted rapidly. If the pattern holds, if the analogy extends to mechanical consequences, we might expect 3I Atlas to begin showing signs of fragmentation soon, perhaps even during the December 19th closest approach when observing conditions will be optimal for detecting such changes. What would fragmentation look like observationally? The first signs would be elongation of the central condensation, the bright spot representing the nucleus appearing stretched rather than point-like, indicating that the nucleus has split into two or more pieces that are close together but separable. As fragments drift apart under slightly different forces, as days and weeks pass, the separation would increase, and individual pieces would become clearly distinguishable as separate objects, each with its own small coma if they're still outgassing. Fragmentation would also change the brightness evolution. Instead of a single object fading smoothly as it recedes from the Sun and from Earth, you'd have multiple fainter objects whose combined brightness might actually be higher than the original single nucleus if fresh surface area gets exposed during the breakup, allowing renewed outgassing from previously buried material. The dust production would spike as fragments tumble and new surfaces erode. The overall appearance would shift from a relatively compact comet with well-defined nucleus and structured coma to a more diffuse extended cloud of material spread along the orbital path. For 3I Atlas specifically, fragmentation would have profound implications for what we can learn from this object, and for how the rest of its journey unfolds. If it breaks apart before or during the Jupiter approach in early 2025, the fragments will follow slightly different trajectories. Some might come closer to Jupiter than others. Some might experience stronger gravitational perturbations. The differential effects could scatter fragments into quite different orbits, some perhaps being captured into elliptical orbits around Jupiter, others being flung out of the solar system on even more energetic hyperbolic trajectories. From a scientific standpoint, fragmentation would be valuable because it exposes interior material, provides direct samples of the nucleus composition from beneath surface layers, allows spectroscopic analysis of pristine interior ices and minerals that haven't been processed by space weathering. We could see what the pre-accretion nucleus, the thermally processed core from the origin system, actually contains. We could measure isotopic ratios in fresh material. We could test whether the interior composition matches the surface composition or whether there's significant chemical stratification. But fragmentation would also end the possibility of studying 3I Atlas as an intact interstellar visitor. We'd lose the ability to measure properties like overall mass and density that require tracking the gravitational effects of a single coherent body. We'd lose the chance to see how an intact nucleus evolves during the Jupiter encounter, how it responds to Jovian gravity and magnetospheric effects. The scientific questions shift when an object fragments, from what is this single object, to what were these pieces before they broke apart. The likelihood of fragmentation depends critically on the nucleus structure and composition. Comets are thought to be rubble piles. In many cases, loose aggregations of smaller pieces held together by weak gravity, and maybe some cohesive forces from ice cementing fragments together. Such structures are inherently fragile, vulnerable to disruption when forces exceed the weak binding strength. But some comets are more monolithic, single consolidated masses that can withstand substantial stress without breaking. Which type is 3I Atlas? The evidence is mixed. On one hand, its survival through a close perihelion passage suggests some structural integrity. It didn't immediately disintegrate when subjected to intense solar heating. It maintained a relatively compact nucleus, rather than spreading into a diffuse cloud. This indicates that at least initially, cohesive forces were sufficient to hold it together against disruptive forces from thermal expansion and internal pressure. On the other hand, the intense activity, the violent outbursts we've documented, the rapid changes in brightness and jet structure, all suggest a fragile heterogeneous interior, where volatile pockets can explode suddenly. That doesn't sound like a solid monolithic body. That sounds like something structurally complex, full of weaknesses, held together provisionally. And now, with volatiles depleted, with the glue of ice cement possibly having sublimated away, the object may be more vulnerable than it was during active phases when pressure from outgassing might have actually reinforced structure by filling cracks and voids with gas and ice. The thermal stress argument is also concerning. Comets experience enormous temperature differentials between day and night sides. The sunlit hemisphere can reach temperatures exceeding 200 Kelvin, where water ice sublimation is vigorous. The night side, only tens of meters away for a small nucleus, remains at temperatures below 100 Kelvin, where most ices are stable. This temperature gradient creates expansion on the hot side and contraction on the cold side, generating mechanical stresses that accumulate with each rotation cycle. For 3I Atlas, having experienced its first intense solar heating in billions of years after its cold interstellar journey, these thermal stresses would be especially severe. The object is undergoing temperature swings from near absolute zero to comet reactive temperatures in just months. The rapid thermal cycling, the extreme gradients, the repeated expansion-contraction, all of these could fatigue the material, could propagate cracks, could weaken the structure until some final stress causes catastrophic failure. And there's another factor specific to 3I Atlas's history that might make fragmentation more likely, the ancient thermal processing we've discussed. If the nucleus really was baked for millions of years during its short-period comet phase in its origin system, that thermal history could have created a specific structural state that's particularly vulnerable to fragmentation now. Prolonged heating could have dehydrated minerals, could have driven off ice that filled pore spaces, could have created a brittle, dehydrated matrix that fractures easily under stress. Think of it like pottery clay. Wet clay is plastic, moldable, flexible. But fire it in a kiln, drive off the water, and it becomes ceramic, rigid and brittle. It's stronger in some ways, but also more prone to cracking if stressed. The same might apply to cometary nuclei. Fresh, pristine comets with lots of ice and relatively unprocessed minerals might actually be tougher, more flexible, less likely to fracture. But ancient thermally processed nuclei like 3I Atlas might have been weakened by their thermal history, left brittle and crack-prone. So multiple lines of evidence and reasoning suggest that fragmentation is possible, perhaps even likely, in the near future for 3I Atlas. The gold colour indicating volatile depletion, the precedent of K1 Atlas fragmenting after turning gold, the structural arguments about cohesion and thermal stress, the ancient processing history that might have weakened the nucleus, all of these point toward an object that's vulnerable, that might be approaching the end of its existence as a single coherent body. And this brings us to the December 19th closest approach, now just days away, which provides the optimal opportunity to detect fragmentation if it's occurring. On December 19th, 3I Atlas reaches minimum distance from Earth at approximately 0.42 AU, about 63 million kilometers. That's not particularly close in absolute terms. Venus can come within 40 million kilometers at inferior conjunction, but it's close enough for excellent observations, especially given that we're dealing with an active comet rather than an inert asteroid. The geometry on December 19th is nearly ideal. The object will be well placed in the pre-dawn sky, rising several hours before sunrise for mid-northern latitude observers, providing dark sky viewing conditions before twilight begins. The constellation location, in the boundary region between Virgo and Leo, places it at comfortable elevation above the horizon, minimizing atmospheric extinction and turbulence effects. And critically, its new moon, meaning no lunar interference, no scattered moonlight to degrade sky background, optimal conditions for detecting faint features in the coma or for resolving fine structure near the nucleus. If fragmentation is occurring, if the nucleus has recently split or is in the process of breaking apart, December 19th observation should reveal it. Telescopes with sufficient resolving power will show elongation or multiple condensations where before there was a single point source. Photometric monitoring will detect asymmetries in brightness, deviations from the smooth light curve expected for a single rotating body. Spectroscopy might show Doppler shifts indicating components moving apart at measurable velocities. All the tools of modern observational astronomy can be brought to bear on detecting and characterizing any fragmentation that's happening. Professional observatories are scheduling time. Gemini North, which captured that beautiful November 26th image, will observe again. Keck Observatory with its 10-meter aperture has allocated time for high-resolution imaging and spectroscopy. European Southern Observatory facilities in Chile will observe during their night as Earth rotates, and different longitudes get viewing opportunities. And amateur astronomers with quality equipment, with CCD cameras on moderate aperture telescopes, will contribute observations that build temporal coverage, that fill gaps between professional observations, that provide the continuous monitoring needed to catch transient events like outbursts or sudden brightness changes. I recommend, if you have the capability, if you have access to telescopes and imaging equipment suitable for deep sky observation, that you try to observe 3i Atlas on December 19th. Even if you don't have research-grade instruments, even if your setup is modest, images from many observers collectively build a comprehensive dataset that captures behavior across time and from different perspectives. And there's something personally meaningful about observing this object yourself, about pointing your telescope at a visitor from another star and capturing photons that travelled light years before reaching your sensor, about being part of the collective human effort to understand what this enigmatic traveller represents. I'm planning to observe myself, going to make the attempt tonight actually, though my current equipment is limited. I'm still building up to the professional grade setup I'll eventually have once I secure property with dark skies and space for a proper observatory. But even with modest gear you can detect the comet, can see its coma, can track its motion against background stars, can contribute data points to the growing observational archive. The location in the sky is straightforward to find if you have star charts or planetarium software. 3i Atlas is currently in Virgo, moving steadily toward the Leo border, positioned between the bright star Spiea in Virgo and the distinctive backwards question mark pattern of stars forming Leo's head and mane. It's at about right ascension 11H31 declination plus 6 degrees as of December 15th, moving slowly eastward at about 1 degree per day relative to background stars. By December 19th it will have shifted slightly, but remains in the same general region, easily located once you're oriented to the constellation patterns. Visually through a telescope, even a moderate amateur instrument, you should see a fuzzy patch, distinctly non-stellar, showing the diffuse coma surrounding the nucleus. The gold colour might not be obvious visually. Human eyes aren't very colour sensitive at low light levels, but imaging with cameras, especially colour cameras, or images taken through different filters and combined, will show the characteristic golden hue clearly. Long exposures will reveal the extent of the coma, possibly show jet structure if conditions and instrument quality are sufficient. And beyond the scientific value, beyond the data collection, there's something profound about witnessing this moment in the life of an interstellar visitor. We're watching an object that formed around another star, that was ejected into the dark, that wandered for unimaginable time, spans through the void that by chance happened to pass through our solar system during the brief instant when humanity has developed the technology to detect and study it. The scale of that coincidence, the improbability that this particular object arrived during this particular century rather than 1,000,000 years before humans existed, or 1,000,000,000 years after we're gone, that perspective is humbling and awe-inspiring. And there are the symbolic resonances we keep encountering, the patterns that feel meaningful even if we can't fully articulate why. The gold colour emerging as the object enters Leo, constellation of the lion, creature associated with gold, with solar imagery, with kingship. The December 19th new moon, darkness optimal for viewing, as if the cosmos arranged timing to maximize our opportunity to witness. The approach to Jupiter, planet named for the king of gods, occurring as the object takes on royal golden coloration. Are these just coincidences, pattern recognition operating on random correlations? Probably from a strictly scientific materialist perspective. The universe doesn't arrange itself around human symbolism. Astronomical phenomena don't occur according to astrological archetypes. Gold comets enter Leo simply because there are 12 constellations along the ecliptic, and Leo occupies 1/12 of that band, and eventually any object on a trajectory through the inner solar system passes through each constellation. The timing is arbitrary from the object's perspective, meaningful only because humans happen to be watching and happen to assign significance to these configurations. But there's also something worth acknowledging about the role of meaning and narrative in human experience of reality. We're pattern-seeking creatures by nature and by evolutionary necessity. Recognizing patterns, finding significance in coincidences, building narratives that connect disparate events into coherent stories, these are core cognitive functions that helped our ancestors survive and that remain central to how we make sense of experience. The fact that these symbolic resonances feel meaningful, that they engage something deeper than pure logic, that might tell us something important about the relationship between consciousness and cosmos. I'm not suggesting literal astrological causation, not claiming that Leo's symbolic associations somehow influence Three-Eye Atlas's chemical evolution. But I am suggesting that paying attention to these patterns, allowing ourselves to feel the resonance, might open perception to connections that strictly reductionist analysis misses. There could be something about the architecture of reality, about the way consciousness interfaces with physical processes, that makes these synchronicities more than random noise. Not supernatural, but perhaps revealing deeper organizational principles that our current scientific frameworks don't adequately capture. And this connects to the spiritual dimension of observing Three-Eye Atlas, the possibility that this interstellar visitor carries or catalyzes something beyond just its physical presence. Throughout human history across cultures, celestial events have been understood as meaningful, as portents or messages or opportunities for expanded awareness. Comets especially, those unpredictable visitors appearing suddenly and disrupting the orderly procession of planets, have been interpreted as signs of change, of transformation, of contact between human and cosmic realms. In the modern scientific worldview, we've mostly abandoned these interpretations, relegated them to prescientific superstition. We understand comets as natural bodies following gravitational mechanics, their appearances predictable, their physical properties explainable through chemistry and physics. And that understanding is valid, important, represents genuine progress in human knowledge. But perhaps we lost something valuable when we reduced comets to mere physical objects, when we stripped away the dimension of meaning and significance that previous generations perceived. Maybe Three-Eye Atlas, as an interstellar visitor, as an object that literally came from beyond, from other stars, from outside the only stellar system humanity has ever known, maybe it offers an opportunity to reclaim that dimension of cosmic connection without abandoning scientific rigor. We can study it physically, measure its composition and trajectory and structure using all the sophisticated tools of modern astronomy. And simultaneously, we can remain open to the possibility that its arrival carries meaning, that our collective attention and consciousness interacting with this visitor might catalyze insights or awakenings that transcend pure material analysis. This is why certain contemplative practices, certain approaches to consciousness that aren't limited to ordinary waking awareness, might be particularly relevant during this period when Three-Eye Atlas is making its closest approach. Meditation practices that quiet the analytical mind and open receptive awareness, dream work that accesses symbolic and archetypal dimensions of experience, plant medicines used responsibly that can temporarily shift consciousness into non-ordinary states where different kinds of knowing become accessible. All of these could be approaches for encountering Three-Eye Atlas in dimensions beyond the physical. I'm not recommending any specific practice or claiming that mystical experiences will reveal literal truths about the comet's nature. But I'm suggesting that the materialist reductionist approach, while necessary and valuable, might not be sufficient for fully apprehending what this interstellar visitor represents. The standard cosmological view of the universe, the framework taught in astronomy courses and presented in science media, captures maybe 1% of what's actually occurring in reality when you include consciousness, meaning, subjective experience, the felt sense of existence that accompanies physical processes but isn't reducible to them. So as Three-Eye Atlas approaches December 19th, as viewing conditions optimize, as professional and amateur astronomers train telescopes on this golden visitor, there's an invitation to engage on multiple levels. Study it physically, absolutely. Collect data, analyze spectra, measure trajectories, contribute to the scientific understanding. But also be present to it contemplatively. Sit with the awareness that this object traveled light years to be here now. Allow yourself to feel whatever response arises when contemplating that journey. Notice what insights or intuitions emerge when you hold this visitor in conscious attention without trying to immediately explain or categorize. And if you're inclined toward practices that deepen or expand awareness, this is a particularly powerful time to engage them. The December 19th new moon, the darkness that makes the comet visible, also symbolizes receptivity, the void state where new perception can emerge. The golden color itself has associations across traditions with illumination, with consciousness, with the solar principle of awareness witnessing experience. Being present to three-eye atlas, whether through telescopic observation, or through meditative or contemplative practice, or through dream states, or through whatever approach resonates with you personally, this could be meaningful, could catalyze something, could open doors in consciousness that reveal dimensions of reality usually hidden by the bright light of ordinary waking awareness and ordinary materialist assumptions about what's real and what matters and what's possible in this strange and wondrous cosmos we're embedded in. So we've established the fragmentation question, the possibility that three-eye atlas might break apart as volatiles, deplete, and structural integrity fails, following the pattern we witnessed with C2025 K1 atlas. We've explored the December 19th closest approach opportunity, the optimal viewing conditions that allow us to detect fragmentation if it's occurring. We've considered both the physical observations we need to make and the contemplative dimensions of engaging with an interstellar visitor during this critical window. Now we must look ahead to what comes after December 19th, to the trajectory that carries three-eye atlas toward its ultimate destination in our solar system, Jupiter. The Jupiter approach, scheduled for early 2025 based on current trajectory calculations, represents the culmination of this interstellar visit. It's the moment when three-eye atlas reaches the most dynamically significant region it will encounter during its passage through our system, when gravitational interactions with the solar system's most massive planet will either capture the object into a bound orbit or fling it back into interstellar space with modified velocity. This encounter will determine whether three-eye atlas becomes a permanent or semi-permanent member of our solar system, or whether it remains a transient visitor, here briefly and then gone forever. Jupiter's Hill radius, that gravitationally stable region, approximately 53 million kilometers from the planet, where orbits can persist without being disrupted by solar tides, is the critical boundary we've discussed extensively in previous analyses. Objects that enter the Hill radius with appropriate velocities can be captured into elliptical orbits around Jupiter, becoming irregular satellites or temporary co-orbitals. Objects that pass through without capture continue on their trajectories, modified by the gravitational encounter but not bound. For three-eye atlas specifically, the trajectory precision we've documented, the fact that its path appears aimed toward Jupiter's Hill radius with accuracy that seems beyond coincidental, raises profound questions about whether this approach is random or represents something more organized. If the object is natural, a comet following purely ballistic trajectories determined by its initial interstellar velocity and subsequent gravitational interactions with the Sun and planets, then the Hill radius targeting is extraordinarily improbable coincidence. Random trajectories don't naturally aim at specific dynamically significant locations. They pass through space following whatever path their initial conditions determined, and the vast majority of such paths miss special locations by large margins. But if the trajectory has been modified through non-gravitational forces, if the asymmetric outgassing we've documented has acted like thrust-producing velocity changes that adjusted the path toward specific destinations, then Hill radius targeting becomes explainable through natural processes, even if those processes are unusual and extreme. This is the tension we've explored before, distinguishing between extraordinary natural coincidence and organized behavior that might indicate artificial control, or at minimum some exotic natural mechanism we don't fully understand. The gold color transformation adds another layer to this question, because it signals the end of the high activity phase, the depletion of the volatile reservoir that was driving the intense outgassing and producing the non-gravitational forces. If those forces were acting like propulsion, if they were steering the object toward Jupiter, then their cessation now in December 2024, as the object turns gold, means the final approach to Jupiter in early 2025 will occur ballistically, under gravity alone, without further course corrections from outgassing thrust. So whatever trajectory has been established by now, whatever path was carved through the non-gravitational forces operating from July through November, that's the path that will carry three-eye atlas to Jupiter. There won't be additional steering, no further adjustments, just ballistic motion modified only by Jupiter's gravity once the object enters the planet's gravitational influence zone. This makes the early 2025 encounter deterministic, predictable, calculable, using standard orbital mechanics once we have precise measurements of the current trajectory state. What are the possible outcomes? The first, and perhaps most likely based on typical cometary behaviour, is that 3I Atlas executes a hyperbolic flyby, passing through Jupiter's vicinity without being captured, being gravitationally deflected but not bound. Its trajectory would be bent by the encounter, velocity vector changed, but it would retain enough energy to escape Jupiter's gravity well and continue outbound from the solar system. The deflection could be substantial. Jupiter's gravity is powerful enough to completely reverse trajectories, to turn inbound orbits into outbound, to scatter objects in almost any direction depending on encounter geometry. If this happens, if 3I Atlas remains on hyperbolic trajectory after Jupiter encounter, it will leave our solar system permanently, heading back into interstellar space on a path determined by the combined effects of solar gravity, Jovian deflection, and whatever momentum it accumulated from non-gravitational forces during its active phase. It will fade from view as it recedes, becoming fainter and fainter until eventually it's beyond detection limits even for our most sensitive telescopes, disappearing back into the darkness from which it came, carrying with it whatever secrets its interior composition might have revealed, if we'd had more time to study it, if it had remained observable longer, if circumstances had been different. The second possibility, more interesting scientifically and more dramatic observationally, is orbital capture. If the trajectory and velocity at Jupiter encounter are precisely right, if 3I Atlas enters the Hill radius at the correct angle and speed, Jupiter's gravity could capture it into an elliptical orbit, making it a new irregular satellite, the latest addition to Jupiter's extensive family of captured objects. This would require extraordinary precision in the approach parameters. The window for capture is narrow, a small region of phase space where velocities and positions must fall within tight tolerances. Natural capture is extremely rare. Jupiter has many irregular satellites, dozens of small bodies orbiting at large distances on highly elliptical and inclined orbits. But most of these were probably captured billions of years ago during the solar system's early history, when Jupiter was still migrating and when perturbations from passing planetesimals were common. Capture events in the modern solar system, in the last few million years, are thought to be vanishingly rare because the conditions that enable capture, three-body interactions where a third massive object absorbs some of the encounter energy, don't occur frequently enough. But there are mechanisms beyond simple three-body dynamics. Gas drag in an extended atmosphere could dissipate enough orbital energy to enable capture, though Jupiter's atmosphere doesn't extend far enough to affect objects passing at typical cometary velocities unless they come extremely close, within the Roche limit where tidal forces would tear them apart. Outgassing providing thrust at the right moment during encounter could also enable capture by reducing velocity at apoapsis, though we've just established that 3I Atlas's outgassing is ending as volatiles deplete, making this mechanism unavailable unless renewed activity occurs. If capture does occur, if by whatever mechanism 3I Atlas ends up in bound orbit around Jupiter, it would become one of the most scientifically valuable objects in the solar system, an interstellar visitor that we could study repeatedly over years as it orbits, an accessible sample of extrasolar material that doesn't require travelling light years to reach. Missions could be planned to visit it, to orbit it, to land on it if the orbit and object size allow. We could answer definitively questions about composition and structure and formation history that remain speculative based on remote observations. But there's a third possibility we must consider, one that's more controversial and more difficult to evaluate: deliberate orbital insertion. If 3I Atlas is not purely natural, if it contains active systems that can provide propulsion, if its trajectory toward Jupiter's Hill radius reflects intentional navigation rather than natural coincidence, then capture might occur through powered braking, through thrust applied at the optimal moment to reduce velocity below escape velocity, establishing orbit without relying on the narrow windows that natural capture requires. This interpretation requires accepting that 3I Atlas might be artificial or at least augmented, that it might be a probe or a vessel or a container of some kind built by technological civilization and sent to our solar system for purposes we can only speculate about. And that acceptance requires extraordinary evidence, requires observations that definitively rule out natural explanations and that positively confirm artificial characteristics. We don't have such evidence. What we have are anomalies, observations that strain natural explanations but don't conclusively prove artificiality. The trajectory precision, the non-gravitational forces with organized asymmetry, the unusual composition with elevated nickel, the survival through perihelion without fragmentation, the curious timing and symbolic resonances, all of these could be extraordinary natural coincidences and unusual but natural properties. Or they could be signatures of technology, hints that we're witnessing something our frameworks aren't equipped to categorize, something that falls outside the binary of natural versus artificial that we use to organize solar system objects. I'm not advocating for artificial interpretation. I'm not claiming that 3I Atlas is definitively a probe, but I am suggesting that we should remain open to evidence, should continue gathering data without prejudging conclusions, should acknowledge that our assumptions about what's possible might be incomplete. If the Jupiter encounter shows behavior that clearly indicates artificial control, if we observe powered maneuvers or orbital insertion under circumstances where natural capture is impossible, then we'll need to update our frameworks, need to accept that we're encountering technology from beyond, need to grapple with implications that are profound and civilization-changing. And even if the Jupiter encounter proves entirely consistent with natural behavior, even if 3I Atlas executes a standard hyperbolic flyby with deflection calculable from gravitational mechanics, the questions raised by this object will persist. The anomalies we've documented won't disappear. The unusual properties will still demand explanation. We'll have learned something important about the diversity of interstellar objects, about how comets from other stellar systems can differ from our local population, about what happens to volatiles during millions of years in interstellar space. The timeline for these determinations is compressed. By late January or early February 2025, 3I Atlas will be deep in Jupiter's gravitational influence, experiencing perturbations large enough to measure precisely, showing whether the trajectory is being modified by gravity alone or by additional forces. By March 2025, the outcome will be clear. Either the object is in bound orbit, captured into the Jovian system, or it's outbound, heading into the outer solar system on its way to interstellar space. During this critical period, observation campaigns will intensify. Every major observatory with capability to track the object will be monitoring it. Astrometric measurements to determine position with highest precision, photometric monitoring to track brightness and detect outbursts or fragmentation, spectroscopy to characterize composition and search for any unusual emissions, all of these will continue through the encounter. And if anything anomalous occurs, if there are unpredicted trajectory changes or sudden brightness variations or spectroscopic signatures that can't be explained naturally, the astronomical community will react quickly, will focus resources on understanding what's happening. For those of us observing from outside professional astronomy, for amateurs and enthusiasts and people who are simply curious about this cosmic visitor, the coming months offer continued opportunities to watch and wonder. Even if our personal telescopes aren't powerful enough to make scientifically valuable measurements, even if we can only see 3I Atlas as a faint fuzzy spot gradually fading as it recedes, there's value in witnessing, in being present to this moment, in connecting personally to events unfolding on scales that dwarf human concerns, but that somehow feel significant to our collective journey as conscious beings trying to understand our place in a vast and mysterious cosmos. And this brings us back to the contemplative dimension we explored earlier, to the possibility that engaging with 3I Atlas on levels beyond pure physical analysis might reveal insights that scientific methodology alone cannot access. The archetype of the visitor from beyond, the stranger arriving from elsewhere carrying unknown gifts or unknown dangers, is ancient and universal across human cultures. It appears in myths and sacred texts, in stories told around fires for thousands of years, in the collective wisdom traditions that predate modern science by millennia. In these traditional frameworks, visitors from elsewhere are understood to be psychologically and spiritually significant, not just physically present. They represent the unknown breaking into the familiar, the other encountering the self, opportunities for transformation that come from outside ordinary experience. The visitor carries something, knowledge, warning, challenge, gift, that changes those who encounter it, that catalyses development or awakening or crisis depending on how the encounter is engaged. 3i Atlas, as interstellar visitor, as literal traveller from beyond the only stellar system humanity has known, embodies this archetype at a scale and in a reality that our ancestors could only imagine symbolically. It's not metaphorical stranger, it's actual arrival from actual elsewhere, from other stars, from conditions and environments and histories completely different from our local experience. And its gold colour as it enters Leo, as it approaches Jupiter, as it moves through these symbolically charged configurations, resonates with the ancient understanding of gold as incorruptible, as solar, as associated with consciousness and illumination, and the highest principles of awareness. I'm not suggesting we abandon scientific analysis in favour of mythological interpretation. Science is necessary, valuable, represents hard-won progress in understanding reality that shouldn't be discarded. But I am suggesting that purely scientific analysis that excludes meaning and significance and subjective experience, might be insufficient for fully apprehending what this encounter with an interstellar visitor represents for human consciousness, for our collective self-understanding, for our emerging awareness that we're not isolated, that our solar system is embedded in a galactic context where other stellar systems exist, and where objects travel between systems carrying with them whatever imprints their origins created. The modern cosmological worldview, the framework taught in universities and presented in mainstream science communication, does capture something real and important about physical structure and process, but it's radically incomplete when it comes to consciousness, to meaning, to the felt sense of existing as an aware being in a universe that appears to be not just physical stuff, moving according to equations, but also experienced, known, felt, meaningful in ways that resist reduction to purely material explanation. So what does it mean that 3i Atlas is turning gold as it enters Leo? That this transformation is occurring as it approaches Jupiter? That we're witnessing this during a new moon that optimizes viewing conditions? That the timing seems almost orchestrated to maximize symbolic resonance and observational opportunity? From strict materialist perspective, nothing. It's just coincidence. Just random correlations that human pattern recognition interprets as meaningful when they're actually just noise. But from a perspective that takes consciousness seriously, that recognizes that subjective experience and meaning are real aspects of reality that aren't reducible to brain states or explained away as epiphenomena, these synchronicities might indicate something profound about the architecture of cosmos, about how consciousness and matter interrelate, about why certain patterns appear and why they feel significant even when we can't articulate exactly why. I don't have answers to these questions. I don't think anyone does, honestly. We're in territory where the maps run out, where the frameworks that serve us well in ordinary circumstances become inadequate, where we're forced to acknowledge that we don't understand as much as we sometimes pretend we do about what reality is and how it works and what our role in it might be, and that acknowledgement, that intellectual humility combined with openness to mystery, might be exactly the stance that allows new understanding to emerge. So as we watch 3i Atlas through these final weeks of 2024 and into early 2025, as we track its golden arc through Leo toward Jupiter, as we gather data and analyze spectra and calculate trajectories, let's also remain present to the possibility that something more is happening than just a comet passing through. Not aliens necessarily, not literal extraterrestrial intelligence deliberately visiting, though we can't rule that out, but something about the cosmos manifesting patterns that resonate with consciousness, about reality organizing itself in ways that generate meaning and significance and opportunity for awakening to dimensions of existence that our ordinary frameworks exclude. The invitation is to engage on multiple levels simultaneously. Use your telescopes, collect your images, contribute to the scientific understanding because that matters, that's real, that advances human knowledge in ways that are valuable and important. But also sit with the mystery. Allow yourself to feel the strangeness and wonder of an interstellar visitor, turning gold as it enters the constellation of the Lion. Notice what arises in awareness when you contemplate this visitor's journey, across light years and billions of years. Be open to insights, or intuitions that might emerge from depths of consciousness that rational analysis doesn't access. And if you're drawn to practices that deepen or expand awareness, if you work with meditation or contemplation or dream work or plant medicines, or other approaches to non-ordinary states of consciousness, this period from now through the Jupiter encounter in early 2025 might be an especially powerful time to engage those practices with 3i Atlas as focus or intention. Set intention to connect with the visitor, to receive whatever teaching or transmission or simply presence it might offer, to open to possibilities beyond what your ordinary waking consciousness assumes is real or possible. I know this sounds far out, sounds maybe too mystical for what's ostensibly a scientific presentation about cometary observations. But I think there's value in acknowledging that the scientific materialist worldview, while powerful and useful, isn't the complete picture, isn't the final word on what reality is and how we should relate to it. There are other ways of knowing, other forms of intelligence, other modes of consciousness that can apprehend aspects of reality that scientific methodology doesn't capture, and perhaps can't capture, given its methodological restrictions. And an interstellar visitor, an object that literally came from beyond, from other stars, from outside the gravitational and informational closure of our local stellar system, might be exactly the kind of stimulus that catalyzes new modes of knowing, new forms of consciousness, new ways of being aware of and relating to the cosmos we're embedded in. Not through transmitting specific information or technology, not through literal communication, but through its simple presence, through the fact that it exists and that we're witnessing it, through the resonances it creates in consciousness when we open to it without preconceptions about what should or shouldn't be possible. So this is my encouragement and my challenge to everyone following this story. Stay engaged scientifically, absolutely. Watch the observations, read the papers as they're published, track the trajectory calculations, follow the fragmentation question and the Jupiter approach and whatever other developments emerge. But also stay engaged contemplatively, psychologically, spiritually if that word resonates for you. Be present to the visitor, not just as physical object to be measured, but as mysterious. Other arriving from beyond, carrying unknown significance, offering unknown opportunities for those who are willing to encounter it with openness and curiosity, and willingness to be changed by the encounter. The gold transformation we're witnessing, the shift from green volatiles to golden dust as the object approaches Jupiter and Leo, might be just chemistry, just mineralogy, just scattering physics determining apparent colour. Or it might be more, might be a sign, might be a signal that we're entering a phase where something significant unfolds, where the visitor completes its purpose, where whatever journey it's on reaches culmination, and those who are paying attention have opportunity to participate in ways that transcend passive observation. I don't know which interpretation is correct. Maybe both are true simultaneously. Maybe the universe works in ways where purely material description and symbolic, meaningful description both capture real aspects of what's happening without contradicting each other. Maybe consciousness and matter aren't as separate as our habitual thinking assumes. Maybe they're aspects of something more fundamental that exhibits both physical and experiential properties, both objective and subjective faces, both measurable structure and felt significance. What I do know is that 3i Atlas has been one of the most fascinating and unusual objects I've had the privilege to observe and analyse in years of following astronomical discoveries. Whether it fragments, whether it's captured by Jupiter, whether it simply fades into darkness on a hyperbolic trajectory, back to interstellar space, it's taught us something, revealed something, opened questions that will persist long after the object itself has disappeared from view. Thank you for following this journey through the colour transformations, through the chemistry and symbolism, through the questions about natural versus artificial, through the contemplation of what an interstellar visitor might mean beyond just its physical properties. If you found value in this 4-part deep dive, if these explorations resonated with something in you, smash that like button, share this with others who might be interested, leave comments about your own observations or intuitions or experiences, engaging with this visitor because this is a collective investigation, a shared exploration, not just my individual analysis, but a conversation that emerges when many minds and many perspectives encounter the same mystery together. And check out the website if you want to support this work materially, if you want to pick up the Interstellar 3i Atlas shirt that lets you carry a reminder of this visitor with you, if you want to try the herb coffee blend that combines the focus of coffee with the neuroplastic benefits of lion's mane mushroom and the nutritional density of dandelion and chicory roots, if you want to explore the spirituality tea blend with chamomile and mugwort and passionflower and purple lotus that enhances dreams and deepens meditative states, and might facilitate exactly the kind of expanded awareness that allows meaningful connection with cosmic visitors like 3i Atlas. Use code THANKSSTEFAN through the end of December for the sale discount. These aren't just products, they're tools for consciousness work, for maintaining the physical and mental clarity needed to stay present to what's unfolding, for supporting the practices that open perception to dimensions of reality that our ordinary awareness filters out. They're part of the ecosystem of practices and supports that allow us to engage not just scientifically, but holistically with mysteries that demand our full presence, our full humanity, our full capacity for wonder and curiosity and openness to transformation. So take care of yourselves, rest well, dream deeply, stay curious, keep watching the skies because they're speaking, revealing, offering invitations to those who are paying attention. 3i Atlas is still out there, still golden, still moving toward Jupiter, still available for those who choose to observe physically, or engage contemplatively, or simply hold in awareness that this visitor from beyond is here now, sharing space with us briefly, before continuing its journey into whatever future awaits it in the vast dark reaches of the galaxy, where most objects spend most of their existence far from any star, travelling alone through the cold void, yet somehow not truly alone. If consciousness is distributed throughout the cosmos, if awareness is fundamental rather than emergent, if the universe knows itself through countless centres of experience that include human observers on Earth, and perhaps also include mysterious golden visitors from other stars carrying within them the imprint of journeys we can barely imagine and purposes we can only begin to intuit. I'll see you all in the next update as developments continue. Until then, clear skies, open hearts, and may whatever 3i Atlas came to teach reveal itself to those ready to receive it.